Dylan, is that your name? Or am I missing it?
Can you hear me?
Yeah, I can hear you.
Cool. Just a bit something with this connection. I don't know.
Yeah, no problem. My eyes are not nearly as good as they were like literally a few months ago. It's actually kind of alarming. Awesome.
Yeah. Well, my name's Dylan. I'm an engineering student. I'm here because I like to learn, and I've been messing around with virtualization for the past 6 years, since whenever I got my first computer.
Oh, very cool.
What kind of engineering?
Right now I'm technically in general engineering because I'm a freshman, and the college I'm at doesn't let I have to pass a entrance exam to get into whatever specific one. But I'm planning to do electrical or computer engineering.
I did
cool.
electrical. It was fun,
Yeah.
especially when you get to the electromagnetic waves.
Now you're talking to the right guy about that stuff. Okay, so I guess we could just get started then. Why don't we give a bit of a quick summary? What is it? Electrical engineering is fun. I did that too. Yeah. So why don't we give a quick summary of the previous call, and then we'll jump into the agenda for this one.
Yep. So previously we announced the MDEV GPU, which is the first suite of tools which will be used for the creation of GVM, which is complementary to the KVM hypervisor, where we focus specifically on mediating graphics cards into multiple different smaller mediated devices, which we can pass into as VMs.
Yeah. So on the previous call, we did our first releases 0.100. That included the first utility. That utility, it effectively interacts with a mediated core. And what it does is it deals with the callbacks function and it deals with the device register interface. So by having free software in that particular layer of the virtualization, what we're effectively capable of doing is virtualizing whatever device we want, rather than having to deal with proprietary blobs that tell us which devices we're permitted to virtualize. Now we're in a situation where we're able to do that. I think later on in the call, we're going to talk about the next component that's going to go into MDEV GPU, which is the MDEV manager. But maybe the first thing that we'll do now that we've just kind of done a quick recap is we could give a couple updates on things. I know, Grant, you were working on a deb package. I didn't quite look at it yet, but I think you made some very valid suggestions. Also, I have to say, Snowman, I love your your video. That's great. Very appropriate.
I've done some little bits on trying to package it up, since it's basically just standalone binary. It's not too hard to put into a Debian package, and I made it basically a test one.
Yeah.
So it probably need a bit more work and double checking to make sure it installs properly. But
yeah, fair enough.
I've sent it out to you.
I think that a very valid critique at this point, though, is like if we are closing in at a point where people who are respectable technologists are going to be using things, we probably do need packages.
We definitely do. So I highly, when we first made the MDEV CLI, I was under the impression I wasn't using too much RAM when I was compiling it. I learned as we were testing out, it's on average about 15 gigabytes of RAM that's required to compile. And at times it can reach 500 plus gigabytes. So I highly recommend that we use packages here.
Yeah, the compile and install thing is probably going to be more difficult as time progresses, I'm imagining.
Yes, I'm doing things to lower the compilation requirements, but they are quite hefty at this moment. Yeah. Runtime requirements are quite small still, so that's a good thing.
Yeah, I did do something where strictly outside of packages, so this is kind of for my own use case and kind of wrapping my head around things. In libvfio now, when you dump the vGPU community driver pack in the optional folder, like the 510 stuff, it will detect that. So if we use the old 461, we just use exactly the same pathway. If it goes to 510 now, it will optionally pull Snowman script. So it asks you, do you want to use the auto merge? It will use his brilliant work for the auto merge. And then it will, at that point, ask you, do you want to install GVM components? And then it'll pull it in, pop it into user. And then I think probably we should talk about the config parameters, right?
Yeah.
Yeah. So there's etc is where we have the config. It's under etc gvm mdev gpu, and it's just generate vgpu types.yaml. The one thing that I think I'm now realizing based on feedback from Snowman yesterday was that as a default doesn't have the vdev IDs. So relying on that will still cause the guest driver to unload. So we probably do need to come up with a fix for that at some point.
Yeah. So a while ago, when we were in the previous community call, we have asked, we have said that is the best way for us to move forward and to actually allow us to enable these functionalities is by no longer restricting the video when it has the virtual flag set to use vGPU functions. Meaning, if you have this one flag set somewhere in the bar space, you are only allowed to actually initialize the GPU with a very specific dev ID and a vendor ID.
Yeah.
And a sub-device ID in the case of Ampere, but Ampere is a bit different where it's kind of friendly in this regard.
It applies also on AMD, where remember when we had the problem initially, we were virtualizing
exactly.
W7800. We didn't know what to do with it because of the device IDs.
Yeah.
Snowman was asking a very provocative question. Are you going to have the language war?
Yeah.
So Snowman was asking, just wondering if Haskell is really appropriate if the build task requires 500 gigabyte of RAM.
The reality is it doesn't. It was only in a certain edge case that I discovered. And that's something that probably can be classified as a bug in the Haskell compiler, but I'm probably not going to report it to Haskell. It's not a damaging bug yet. Anyways, to answer the actual question of whether it is appropriate language, we have found that it allows us to have a much nicer mechanism for
memory offsets.
Yes, the memory offsets, and the memory offsets are without a doubt the single most grueling and most complicated part of dealing with this NVIDIA vGPU system.
Yeah, like originally this was Rust.
Yeah,
we actually left Rust behind largely because of the offsite calculations.
Yeah,
very annoying.
Exactly. If Rust was able to let me say exactly where in the memory map each component is, we would be using the Rust. OCaml is a little bit better in terms of compilation speed. I haven't worked with it enough to actually know for certain whether or not it will be better in this particular case, because what we absolutely need, because we don't have the same tools NVIDIA has, we have to actually say this offset is correlated to this particular memory address in this particular object, and that is why we picked Haskell.
Yeah. So Ricey says is not a damaging bug. I have 1 terabyte of RAM in my system. Yeah, exactly.
There's a story about Haskell users. One version of the Haskell compiler would delete the source code if you had a type error. And when people were reporting this bug, they went to reporting it like they do in some other programming language. They just said, hey, this is no problem, no need to fix this. I already have a script that backs up my source code now. But
oh yeah, you're talking about the self-deleting Haskell bug?
But I figured you might want to know that this bug exists.
Yeah. Okay. So maybe now that we've kind of covered all that, obviously there's going to be a degree of remaining confusion around actually how to configure MDEV GPU. So the defaults are not suitable as is. I think we do need to specify, the VDEV ID. So really the only way that we're going to be able to do that, I think, is probably going to be copying from the mechanisms that we used in libvfio, where libvfio actually had like a profile like NVIDIA 20XX, and here are some device IDs that we know work. We're probably going to have to provide that in the NVIDIA folder under etc, GVM, MDEV GPU, and NVIDIA. Have suitable VDEV IDs, because obviously that's been an area where people are tripping up.
One beauty about the ways that we built YAML for this one, we can have all of them in the exact same YAML. So we just release one YAML.
Yeah, we could do that. That's a potential way we could do it. The way we'd have to then have people see the documentation, though, would be to go in and know this profile with this device number is appropriate for my device, as opposed to it being like pick this this file in this folder, depending on your card. So the trade-offs either way.
Of course. Maybe we'll have the ability to read sub YAMLs.
Or we can just name the GPU device like based on the particular card. That would probably work.
That works as well.
Because we can have like 500 different profiles or something. An enormous number, right?
So we have two new members, Skyla and Dylan. What would actually make the most sense for you guys, as you guys are still new to this field?
Well, I'm still trying to get a lay of the land. So I, without a doubt, have questions. I just fear they're a little bit on the basic side. Sure. If those questions are all right in this
video, go for it.
Okay. So, for instance, I'm looking at the GPU support page right now on openmdev.io. And I see how different architectures are supported by different layers of our protocol, protocol. So just to make sure I understand this, MDEV is something that is kind of already in the Linux kernel, the mediated core. Okay. And then as part of the package for the VFIO MDEV, it comes with the VFIO MDEV driver.
So the VFIO mediated device was actually a pull request by NeoGia and Kriti Wankid from NVIDIA into the Linux kernel. I believe they actually did that in collaboration with IBM, Red Hat. At the time, it was a separate company. And then what was the third? It was Intel, or sorry, the fourth was Intel. So that is now in the kernel. There's no specific requirement for you to install the VFIO MDEV package. The way you can read the support page is it's based on different levels of hardware assistance, right? Like, for instance, back when we had early Zen virtualization, the Xeno servers project from Cambridge, they had like basically a method by which they could virtualize the GPU, or the CPU, which did not require any kind of hardware assistance, right? Like they used, was it shadow registers, and then they would basically, they used ring deprivileging, and they put everything like, kernel and user land for the guests into ring 0. Those are PV guests. We're kind of in a similar situation today where it's like we can virtualize basically any device, and whether or not we use hardware assistance is large. V is an example of a hardware assistance mechanism. SIOV is another example of a hardware assistance mechanism. But if we don't have it, you just use the base virtual function IO mediated device API. So it's all a question of how we cut the cake.
Oh, okay. So and you cut out for a moment there, just to make sure I understand. SRIOV is a method that is basically hardware assisted.
Correct.
And MDEV is getting at a similar solution set, but doing it in software.
Yep.
And then
is my mic still working?
I think so.
It is. I was just wondering because I didn't know if the thing was.
Oh, maybe it doesn't.
Is it not working?
Can you hear me?
So software. So MDEV can be both software and hardware assisted. So MDEV is more abstract. It's the next step. So previously we only had SRIOV and VFIOs. Now what is happening is we're trying to increase the range by all vendors. So, for example, Intel and NVIDIA are both working quite hard on implementing more MDEV features into the system.
Should we go to just like the basic differentiators between them?
Yes.
Okay.
Yeah.
So the main thing you can think of is like when you have SRIOV, typically, like if you were to go way back to like an early implementation with, for example, some of the earlier GPU IOV module stuff from AMD, you get bus slot function, and you would just bind that device, basically the address for bus slot function, to VFIO PCI, and you would send that into a guest. So basically, the device itself is creating virtual functions at an actual PCI address, and you can send them to the guest. VFIO MDEV basically is very similar, but it creates a sysfs dev device, which is in a sys MDEV bus, something in the kernel path. And then that device, basically, it's kind of an IOMMU group, kind of not. There's some changes to the type 1 IOMMU API that I think allowed for there to be like pseudo IOMMU groups. That's kind of IOMMU groups are kind of a core concept in virtualization of devices and directed IO, that kind of thing. SIOV is where things get really interesting because that looks like it's next generation, where it basically involves a combination of things like hardware mediated pass-through and basically software mediated pass-through. So you think of things like, imagine if rather than having like the CPU in the context of VFIO MDEV or the platform control how the IOMMU allocations work, it's actually the device. So the peripheral is controlling it. And you can do really interesting things, it looks like, with SIOV. Like, for example, you can have pages in VRAM that have the same address space. So like I could say, if I have a mesh or a texture or, some weight in a neural network or something, which has been duplicated like 30 times on the VRAM, why not just have the shadow page point to the same address? Why do you need that copied like 30 times? So that's kind of where things are going. But where things are probably going to become free software is in that, the first layer where things are the VFIO MDEV stuff. So you'll see folks getting access to GPU virtualization for the first time as free software, while all the crazy proprietary stuff like disappears into chipsets that are on embedded controllers, and people will have new proprietary drivers, that kind of thing.
The best scenario, in my opinion. But this is a very interesting explanation. I was under the impression that MDEV was more a software-based solution and not a mix of both.
So
it is actually a software-based solution. That's exactly accurate. I meant to say that like SIOV was a mixture of the two concepts.
Oh, okay, that makes sense.
So MDEV is an abstraction layer at the end of the day.
Sorry, but one clarification. I meant people aren't familiar with SIOV. It's a scalable IO virtualization. It's a new level. Yeah. It's a new abstraction.
Yeah. So MDEV is just an abstraction layer. It's an interface. This interface can be supported by either a hardware-backed system or a software-backed system. So it is a mixture of both in that regard. What the question is, who implemented the interface on the driver side? That's it.
So, for example, is NVIDIA's MDEV solution a software-based one?
Half and half. So
depends. Are we talking pre-Ampere or post? Because we still use VFIO MDEV. So pre-Ampere, yeah, it would be a software solution.
Yeah.
Post is not a software solution. It's a very much a mixture of those concepts. In my opinion, and this is purely my view, I think that NVIDIA was thinking ahead of Intel because Intel started doing similar things with SIOV, but it seems like they just kept it to themselves.
It was only really for like enterprise use cases too, like cloud gaming, compute, that sort of thing. Because
there are some interesting things that we can probably talk about after.
In the unrecorded section. Do we want to give a quick update for MDEV Manager and then hop into the unrecorded section?
Okay, yeah. So the MDEV Manager stopped being 500 gigabytes to compile. I know that Snowman would have preferred all to be in C code.
Yeah.
But I find it a little bit easier to develop it inside Haskell, and then we can move it to whatever one. We're planning to use a Haskell system more as a prototyping layer, so that we can actually figure out the problems faster. I've been running into an issue where I keep putting in the vGPUs into invalid states.
You're talking about the blacklisted pages thing?
No.
Oh, no, that's
invalid
the-
states.
Yeah, okay. I was thinking of a
but,
different bug.
What would invalid states mean?
Invalid states meaning it cannot find a certain component. So the particular invalid states I've been working with are when you have a VM ID. Well, not just this, but a few other things. Basically, think of the entire system as a series of state machines. So state machines can sometimes go into certain states. And what I'm trying to do is I'm trying to jump from one state to another state, but I'm not able to jump through those states because I have to go through an intermediary state, and that intermediary state doesn't exist. Therefore, I am placed into an invalid state condition. This is the bulk of the problems we have been facing in this thing. But finally, we have managed to attach MDev to the VM and not have it crash instantly. It doesn't load the driver, but it doesn't crash instantly anymore.
Yeah. So
I think
maybe
it's
by
big progress now.
yeah, so maybe by the next call, maybe by the one after that, we'll have something to share on our following release. Okay. Did you want to take a question and then we'll hop in, or what?
To respond to Snowman.
Wait, so do you want to repeat what he said?
Yeah. So Snowman was saying that when he compiled the Haskell code that peaked at 8.5 gigabytes, that is for MDev CLI,
Right.
not for MDev Manager.
Yeah, so the current release model is typically what we end up doing is we develop software until basically it looks viable, and then we'll release it as free software. That's the tendency that we have. We have some bits that are closed source, probably will never be open source, but for the most part, everything we do is eventually winds up as open source. But yeah, that's not in the current release.
Yeah.
Yeah.
There are certain things there which me trying to figure out how NVIDIA did certain aspects.
I think also
I'm happy to send to collaborate with you in case you're interested on this stuff.
One of the things I think we ought to look at as a learning experience as well is how amazingly I think we documented when we released libvfio. We released these install guides, we released videos, we released here's exactly the use case, here's a bunch of tests. We had people come in and actually run through the guide and see whether or not they got tripped up on anything. And then when we released MDev GPU, we were kind of just like in this rabbit hole of like, oh look, there's like 5 people that we interact with in the world that are all thinking at that layer. Let's just release this and it'll be obvious to everyone what's happening.
But we have solved one of the main complaints that we had with libvfio. We have added a help dialog from the beginning, and we have added documentation on every function.
Yes, but just not explaining what the thing does.
Exactly.
Yeah. So anyway, I think it's going to have to be for future releases. We'll have to learn from libvfio and what we did really well there, and what we didn't do great when we released the first version of MDev GPU. So going forward, we have some improvements to make on that. Okay, I think we'll start the unrecorded section now.